Our idea is to implement a programmable LED matrix in which we can implement a minigame, which shows progress as the minigame, because it's a very simple game and it's very fun to play. And although the idea might seem quite simple, it's actually very hard to implement. But thankfully it was a very fruitful experience. We used an 8x8 LED matrix, an Altera DE215 board, a breadboard, and a few wires. The game itself is about a frog that has to cross to the other side of the river while avoiding the obstacles. The player has 5 lives and he has to win 9 lives.
Before starting in our project, we have to first understand how the LED matrix works. Since we have an 8x8 LED matrix, we know that we are dealing with 64 LEDs. Having 64 LEDs will be so inefficient to connect to the FPGA, since it will be so messy to connect 64 outputs from the FPGA. So we need to minimize the number of the outputs from the FPGA. In order to do so, we can use 1 wire per each column and 1 wire per each row, meaning that we will have 8 wires to the anodes and 8 wires to the cathodes. Like this, we will use a completely parallel circuit with a minimal number of wires. And in order to light up the LEDs that we want to light up, we use a process called the multiplexing process. The multiplexing process is a process in which we light up 1 row at a time. But we do this process so fast that the human eye cannot notice the blinking of the lights. And using this technique, we can create any shape or any animation we want on the LED matrix.
We got 1 single LED and we tried to light it up using the FPGA board. Then we make it pink. First we made the whole LED matrix light up. Then we made an LED dot that moves across the whole LED matrix to make sure that we can access each LED individually.
After making sure that we can control each single LED, we started implementing the multiplexing process. In order to do so, we implemented a fast clock that loops through the whole matrix, lighting 1 row at a time. Rows change, the column also changed in order to light up the LEDs we want to light up. We are able to implement the multiplexing process. We now are able to make any shape we want on the LED matrix. So now we will start implementing the game.
In order to implement the game, we program the FPGA to take 4 inputs which are represented in an array called move. Each bit or each input in this array represents a direction in which the player can move. We assigned each of these inputs to a switch on the FPGA. We also programmed the FPGA to give 16 outputs, 8 for the anodes and 8 for the cathodes. Are represented as 2 arrays in the Verilog code. Then outputs are assigned to a GPIO pins in the FPGA.
In addition to the 16 outputs used to control the LED matrix, we also have 14 other outputs used to control the 7-second display. One is used to display the current level, the other is used to display the current lives.